The Sun will swallow 2 planets and then quietly stop. We said in the episode about the Sun that it will never explode, and that is still true. It is not massive enough. What it will do instead takes about 1 billion years and is mostly slow. When the hydrogen in the core runs out, the core contracts and gets hotter, and that heat pushes the outside of the star outwards. The Sun becomes a red giant. Red because the surface, spread over an enormous area, is cooler than it is now. Giant because it will reach out past where Mercury and Venus are. Those 2 planets go. That part is not in doubt. Earth is genuinely unsettled. The reason is not the size of the Sun. It is that by then the Sun will have blown away a substantial part of its own mass, and a lighter Sun holds its planets less tightly, so all the orbits move outwards. Whether Earth moves out faster than the surface comes in depends on numbers that different models handle differently. Papers have come down on both sides. It does not matter much either way. The oceans will have gone about 1 billion years before that, from the slow brightening that is happening now. Then the outer layers drift off. Not blown, drifted, at a few tens of kilometers per second, which is slow for this subject. The core is left behind, naked and very hot. We are confident about all of it, because we can see other stars at every stage of it, right now, at different distances. Nobody is waiting 5 billion years. The whole sequence is laid out in the sky simultaneously. A star once appeared in daylight, and somebody wrote it down. On the 4th of July, 1054, court astronomers in China recorded a guest star in the constellation we call Taurus. Their records are specific in a way that is very useful 900 years later. It was visible in daylight for 23 days. It remained visible at night for 653 days, and then it faded and was gone. Japanese records mention it too, and there is a probable reference in an Arabic medical text. In the same part of the sky, there is now a cloud of shredded gas about 11 light-years across, still expanding at around 1,500 kilometers per second. Wind the expansion backwards, and it converges on a point at a date close to 1054. At the center of that cloud is a neutron star turning 30 times a second, and it is still feeding the cloud energy 970 years later. The whole nebula glows because of it. That is the cleanest connection in this episode, a line written by an official in a court that has been gone for centuries, and an object in a telescope tonight, and they are the same event, and the arithmetic joins them without any help. One of the bright stars of winter will go, and nobody can say when. The orange one on the shoulder of Orion is a red supergiant. It has already left the main part of its life, and it is near the end. Almost every number about it is uncertain, and this is worth stating plainly. It is close enough that its distance is hard to measure well, because the star is not a point, and its surface boils in enormous patches that move the apparent center around. Estimates run from roughly 400 to 700 light-years, and the mass and the timing depend on which is right. The best that can honestly be said is that it will explode as a supernova sometime within the next 100,000 years or so. That is tomorrow in one sense, and never in any sense that concerns anybody alive. In late 2019, it dimmed noticeably by more than half its usual brightness and stayed dim for months. It was widely reported as a possible warning. Observations with the Very Large Telescope, published in 2021, explained it. The star had thrown off a cloud of gas that condensed into dust in front of it over a cooler patch on its surface. Not a countdown. Weather. When it does go, it will be roughly as bright as a half moon, visible in daylight for weeks, and completely harmless at that distance. Then Orion will be missing a shoulder and stay that way.